Hi guys. So sorry for the delay, and I thought of making this video for our physics. So this is the first physics discovery we are going to make, an intuitive understanding towards physics. So I have asked some lot of questions the previous time. So I will try to answer one by one. So and also that I have a good surprise for you actually. Instead of making just myself speaking to you, and most of the time you won't get bored, so I thought of making some animated videos so that it will be easy for you to grasp those concepts. So actually this time the question is, what really did Newton find? So actually you might have heard in classes and the people narrating that Newton has discovered gravity. What actually did Newton discover? Actually, we had heard some stories that apple falling on his head. So he thought, what is the force pulling this apple towards me? So he discovered it's gravity. So what he had discovered is that he gave a name, that whatever the force is pulling the apple towards me is, he given the name gravity. So he is famous. So that was the kind of idea which was bugging me for a long time during my childhood. People and teachers, most of us misdirect in this way. So actually, if you see into what Newton really find, this is really astonishing once you get a real feel of it. So actually, if you see what really Newton find is, he hasn't discovered gravity. He discovered how gravity works. That's the real idea, and he said that the entire universe is held due to gravity. That is the most non-intuitive idea he had made. If we see, it is not a kind of intuition or obvious thing to discover what Newton did. He has made a tremendous idea. He made that the entire world is held by the gravity. So let us see what really gravity is. He just discovered a phenomenon. So you just have two balls. Normally, I'll just start off with another question. So if you have 1 kg of cotton and 1 kg of stone, which one will weigh the more? Basically, some people might have reasoned this question, but most of the time, if I ask you for the first time the same question, then you will say the cotton will weigh the more. Sorry, they will weigh the less and stone will weigh the more. Actually, the basic idea is both of them are 1 kg and both of them will weigh the same. But we have feel that cotton is weighs lighter and stone weighs heavier. So okay, so let us take two balls, one made of iron and one made of plastic. So if I drop both the balls from certain height at the same height, so one is made of iron and another one is made of plastic. So which one will hit the ground first? Actually, we normally think the heavier one, which has a huge mass, will hit the ground first. But actually, both of them will hit the ground at the same time. How it is? Actually, the iron is more heavier, so it will have more force, right? So it will hit the ground faster than the plastic ball. That's our intuition. But if you really get your mind into it, then you could see that the heavier ball has heavy force than the plastic ball. The fact is true. This has a heavy force, this has a lesser force. But if you see, the acceleration of the ball towards the earth is the same. So even if as the mass is more for the iron ball, its force is more, but the acceleration is same for as that of the plastic ball. It has more mass, it has more force, but the acceleration is same. This is the critical point. So both of them accelerate at the same rate as they fall towards the ground. So this is the kind of idea. Okay. So I'll just ask another question, that if you take a gun and if you shoot a bullet and drop a bullet, which one will hit the ground first. Actually, if you see, the bullet travels faster, will hit the earth first, right? That's our intuition, but actually the case is both of them will hit at the same time. That is again another thing. If you fire a bullet, you are firing tangentially. That means it is completely parallel to the surface of the earth. That means it is perpendicular to what gravity is. If gravity is pulling this way, you are completely firing the bullet perpendicular to it. So the gravity accelerates the bullet downwards, even if it is not accelerating. So this acceleration doesn't count into the acceleration due to gravity. So both of them are kind of the same. So even if you fire a bullet and drop a bullet, both of them hit the same earth or the ground at the same time. So people have really captured this moment, and I have added the link into the comment section. You just go and watch this YouTube video. This is really awesome, that even if you fire a bullet and drop a bullet, both of them used to hit the ground at the same time. That is really. So okay, let's get into Newton's idea. So this is kind of an idea. So I just made a video, just get an idea. Just this is made of balls. So as give you a real feel of how this happens. Just watch this. Hi, you might have watched this thing. Really good, right? So no matter how hard you push it to the side, both of them hit the ground at the same time. Really good understanding. So okay, so again, how does Newton relate this one, and what does the universe held up? So okay, let's see. There is a famous concept called Newton canon. So okay, just we'll climb up Mount Everest, and we'll set up a cannon at the top of the Mount Everest. So okay, even if you drop a ball, as of the surface, you see, even if you throw something or put something, it just hits the ground, right? Because you see that the ground is flat. But if you see it in a large scale, actually Earth is not flat, right? It is a curved ball of sphere. So if you fire something with a great velocity, so think of it that what happens is the earth is curved like this. If you fire something, what will happen? Will it get out of earth? So this is kind of a different idea, right? So this is what Newton has been thinking about. Just appreciate it. So so this what he had thought is, if I can fire a cannon at the surface of the earth, it is round. So what happens if it leaves this surface? So what it happens to fall somewhere around? So then this idea came that no matter whatever you're pulling it, the earth used to pull your object towards the earth, right? So even if it gets here, it gets pulled in the earth. So okay, whatever I fire up with some higher velocities. So okay, I just made some video, such as how the just with a bigger blue color one, assume that as an earth, and someone ball being dropped, and one is dropped straight, and I'll just increase the velocity of the ball while dropping a little bit to the side. So what happens? Let's see the video, that what happens if I increase the velocity bit by bit. I hope you have enjoyed it. A really nice one, right? So, as long as you increase the speed, it instead of hitting the earth, it starts to rotate around it. This is the great idea that Newton has discovered. That is what making the planets go revolve around each other. So such a great idea. Just sitting in the earth, he discovered that how planets go around the sun or a star, or satellites go around satellites in the sense the moon go around planets. So we really use this idea to make our satellites, the one with the solar panels and those things. We just use this concept to make these our satellites go revolve around Earth. So that hope if you are watching this video, thanks to Newton, that it is transmitted through such satellites and getting to your homes. But actually speaking, it's not. It is getting through optical fiber. Just leave this thing. Actually, previously it was like that. And if you are watching a TV in your home, just appreciate Newton that he had made the basic discovery for what you're watching at your TV right now. So, so how really he did thought of it. So okay, I just fire out something at near Earth's surface. So it accelerates. It is going at some velocity, right? So what happens when it crosses this curve? So the Earth tends to pull it towards this Earth, and what happens is its velocity is such a way that this velocity turns a little bit. So it turns a little bit, and it just makes a round around this. The bigger one. So this is the kind of one idea that is mind blowing. So this makes the thing to go around. So if you just see how this orbital velocity came, it just passes this edge such that it is shot in such a velocity that each of the time it moves around, it tries to hit the earth tends to curve away from this projectile. So once this object is fired, so it is trying to fall near this, but at this time this earth tends to curve away. So what happens is each and every time it is trying to hit the earth is getting away from the object because of the curvature of the earth. So this is pretty crazy idea. So as Earth is curving away from the object, what do you think the object is going around with it? It is continuously falling, but it never hits there. That is the kind of idea. So it is continuously falling, and it tries to hit the Earth, but Earth curves away from the object, so as this distance is maintained. So actually, if you have seen it, I think it's around x equal to 8, right? X is equal to 8 is a perfect spherical orbit. That means it travels in a speed such that whenever it crosses these lines, the height from the Earth is maintained constant, so that this makes a spherical orbit. But most of the time it is not exactly calculated, right? So it obviously becomes an elliptical orbit, slightly away from this spherical one. So this is a kind of natural thing happening. So this is the reason behind the elliptical orbits. I think you might have had some good idea about why this. You might have think a spherical orbit will be a better one. Why does it go for an elliptical orbit? So now you have the point. The spherical orbit just happens at a critical moment when this velocity is in such a way that it travels in a way that the falling of the object and the turning of the curvature of the Earth both are maintained at a constant speed. So it is not always the true. So that's why we are having elliptical orbits around that. So even if you get a speed a little bit increase, so you might have seen it again gets into elliptic. So it passes away. So again, due to attraction, it just gets in, and this becomes an elliptical orbit. So again, we might have heard about escape velocities during the school time. You just throw something with some velocity so that it doesn't come back to Earth. So So I think you might have, at the last one, you might have get a good understanding that it is traveling at a speed such that this pulling doesn't even matter, such that it passes away from there, and once it escapes the gravitational field, it just travels on at a straight line. So this is what a great idea behind this. Okay, so what will be for our next video? So okay, I will just put up the question. So we really remember Newton's third law, right? For every action, there is an equal and opposite reaction. Why don't we remember the first and the second law? Most of us forget all this time, right? So why do we forget, and what does this thing really mean? We really know the third law, but why not the first and second law? So keep this thing around your head. I'll catch you up in the next post, and thanks for watching.